Okay, so we are going, excuse me, to get started with lecture 27, part 2. This is where we are actually going to go about graphing these functions here. Um, so we will start out with, we need to learn or relearn, we've already done this before, finding the domain of these functions. Okay, then a new step is going to be, does the graph intersect the horizontal slash oblique asymptote? Okay. And then we will also go over finding the x and y intercepts. And then the fourth thing we will do is we will actually be graphing these functions as far as figuring out what all these pieces that we found from our asymptotes, x and y intercepts, if it crosses the horizontal or the oblique asymptote. And we will kind of get a feel for what's going to happen with that there. So let's start out with our domain. Okay, so what do we need to remember about finding the domain? Well, when we're finding the domain, we should be looking for any concerns. So what is our concern when I am dealing with a rational expression? So f of x equals x squared plus 3x minus 10 over x squared minus 2x minus 8. What would my concern be for this? Well, we would be concerned about the bottom equaling 0 because we cannot have the bottom equal 0. So the bottom cannot equal 0. Okay? So if I'm worried about the bottom and making sure that it does not equal 0, okay, when I do that, I need to make sure that the bottom, so when I find the domain for a rational function, I'm going to look at the bottom, x squared minus 9 cannot equal 0. So x squared minus 9 cannot equal 0. Okay? You can solve this one. You can also factor it. If you remember, x squared plus 0x minus 9 cannot equal 0. Okay? This one is a difference of squares, so you can factor it with a 0x, or you can just have that memorized that it's a difference of squares. Factors of 9 that subtract to give me 0 would be 3x and 3x. So I'd have 1 plus, 1 minus. Pull out an x, leaves me with an x minus 3. I could pull out a positive 3, leaves me with an x minus 3. And I get that x plus 3 times x minus 3 cannot equal 0. So I'm going to set both of those there. X plus 3 cannot equal 0, which means that x cannot equal negative 3. And x minus 3 cannot equal 0, which means that x cannot equal 3. Okay, and then remember we have to write these in our interval notation. So when I write this, I would write it as negative infinity. Wow, that is a bad infinity sign. Negative infinity, comma, negative 3 in union with negative 3 to 3 in union with 3 to infinity. Okay, so that would be my domain. Now, that domain should look familiar, okay, because the domain is the exact same process that we do to find the vertical asymptotes. Okay, so once you find your domain, you really don't need to worry about showing any more work to find your vertical asymptotes, because the vertical asymptotes for this function, I set the bottom equal to 0, okay, which gives me that x equals 3 and x equals negative 3. Okay, so once I show the work for one of the domain, you really don't need to show your work for the vertical asymptotes. Okay, so that was just kind of a refresher there. The next thing that we are going to talk about is we are going to talk about if the graph ever intersects the horizontal or oblique asymptote. Okay, so starting out, we know that when we find the asymptote, we have a y value. We have a y value that is present on the graph. Okay, so we get something like y equals 1 for our y value. So I know that the y value of 1 is present on the graph. So if I want to know if that intersects, I need to set our function equal to that y value. So we need to set the y value of this function equal to whatever we found our horizontal or oblique asymptote. So starting out then, okay, for this one here, I have a degree 2 and a degree 2. So since their degrees are the same, I'm going to look at the leading coefficient over the leading coefficient. So I get that y equals 1 over 1, which gives me the horizontal asymptote of y equals 1. Okay, so I guess I picked a good number up there for that one. Okay, so we have y equals 1. So if I want to see, does this thing intersect, okay, I'm going to take that 1 from y equals 1, and I'm going to plug it in for my y value, which is just my f of x, okay? So I'm going to plug this in, instead of f of x or y equals, it's going to be 1 equals x squared minus 6x plus 8 over x squared minus 9, okay? So to test, we set our function equal to that y value from the horizontal asymptote. That was my 1 there, okay? Now, once I do this, I'm just going to solve. So the first thing that I need to do is I'm going to need to get that x squared minus 9 off the bottom. So if I multiply this side times that x squared minus 9, those cancel, okay? Do it on this side as well, x squared minus 9, okay? That 1 has to distribute to both, which when it's a 1, it doesn't really do much. But, if that's a 2, make sure it distributes. That gives me an x squared minus 9 equals x squared minus 6x plus 8. Okay, and now I just need to solve for x. So if I have an x squared, the first thing that I need to do is I need to get all that over so that I can factor. That cancels. Oh, and that cancels too. So I end up with a negative 9 equals an x squared, x squared canceled, I'm sorry, equals a negative 6x plus 8. Okay, so I need to go ahead and add my 8, or subtract my 8 over, subtract my 8. I get negative 17 equals negative 6x. Okay, and when I do that there, I end up with 16 over 6x. Okay, so what that tells me is when my y value is 1, my x value is 17 over 6. So that means it crosses the horizontal or oblique asymptote at the point 17, 6, 1. So I know for a fact that it crosses the horizontal asymptote at that point. Okay? Now, there are going to be some other options, and I will talk about that when we actually get to graphing, but that is how you tell if it crosses, okay? So how do you tell if it doesn't cross? So if it doesn't cross, what this is going to look like, okay, is it would be something like, let's say 1 equals x squared plus x minus 6, and x squared plus x minus 12, okay? So I would multiply both sides by the bottom, and I get x squared plus x minus 12 equals x squared plus x minus 6, okay? So I need to solve this. Minus x squared minus x squared minus x minus x. And when I do that, all of these cancel, and I end up with negative 12 equals negative 6, okay? Now that is not true. That is false, okay? So if you get something that is not true or false, okay, if it's not true, meaning that it's false, then that means that it doesn't cross, okay? So if you see something like this, that is how you know that it does not cross the horizontal or oblique asymptote, okay? So we got one more thing to talk about. We've got our x and y intercepts, and then the last thing we have is just our graphing, okay? So quick review, how do you find your x and y intercepts on this? Okay, well, to find my x-intercepts, I set y equal to 0. To find my y-intercepts, I set x equal to 0. Okay, so for this problem down below here, let's go about finding my x-intercepts. Okay, so I need to set my y equal to 0. So I've got y equals 0, and that equals x squared minus 6x plus 8 over x squared minus 9. Okay, I need to get rid of the x squared minus 9, so I multiply that on this side, just like what we did. Now, when I do that, 0 times x squared minus 9, that ends up giving me 0 equals x squared minus 6x plus 8. So really all you're doing when you're finding the x-intercept is you are just looking at the top. The top of the fraction will tell you what the x-intercept is. Okay, so I'm going to go about factoring this. And when I do that, I'm going to skip some steps here, but this gives me an x minus 4, yep, and an x minus 2. Maybe I shouldn't have skipped steps there. Gives me x equals 4 and x equals 2. So I know that this has I know that this has x-intercepts of 4, 0 and 2, 0. So my x-intercepts are 4, 0 and 2, 0. And I got that because I set my y equal to 0. Okay, now find my y-intercepts. Okay, so to find your y-intercepts, we need to set x equal to 0. So y equals 0 squared minus 6 times 0 plus 8 over 0 squared minus 9. All those x's now have zeros plugged in for them there. Okay, so essentially what happens, everything cancels, and I am left with an 8 over a negative 9. So I find that my y-intercept is 0, negative 8 ninths. Okay, and that is your y-intercept. Okay, in the next video, we will go about how we can use all that information that we just found and actually graph these functions.